Hello, 7th grade, and this is Chapter 8, and in tonight's lesson, we're going to look at relations and functions. All right, our objectives are that students will be able to determine whether a relation is a function, and tonight we're going to show how to do that in two different ways, by mapping them and then by graphing them and looking at the vertical line test. And then secondly, you will be able to graph relations and functions. So let's go ahead and get started. And we're going to skip the warm-up and go right to this. When we talk about a relation, it's a set of ordered pairs. And we've done ordered pairs before. That's when we talk about 2 to 7 or something like that. It's in parentheses. And this is when we normally graph them. You find x is 2, y is 7, and so on. Well, here we can have a set of information. Like here, we have the number of students with the number of cans brought in. Well, I can make a relation on this. And what I do is just take each ordered pair. This is 1, this is 1, this is 1, and so on. And then I'd have this. Well, 25 to 133, 22 to 216. And again, I'm just putting a comma between each ordered pair here, or each set of ordered pairs. 22, 195, let's see, 2 left, 20 to 74, and finally 21 is 250. There we go, and put the other bracket around it. So this is considered a relation, what I just did in red. Okay, so when we talk about a relation, it's made up of two different things, a domain and the range piece of information. The domain is the first coordinate in each relation, also known as the x value. So the first piece of information, which I'm underlining in green. While the range is a second coordinate, which is y. So in some of these situations, they're going to ask you to tell the domain and range. So when I do the domain, again, I'm going to make that little bracket, and I can write the domain. I see 25, 22, 24, 22, 20, 21. All right, you could write them in the order they have them, but really you should write them in numerical order. So with the smallest first, 20, 21, 22. Now, I notice I have another 22 here, but you only write it down once, because once you write 22 as a domain, it covers all 22s. So then I'm going to go right to 24, then 25. That would be considered my domain. Now, same idea for the range. I write range, make my little bracket, and then I take a look at what I have. And again, I'm going to start with the smallest one, which is 74. Then it looks like I do 133, 148, let's see, 150, 195, and 216. There we go. So again, I just gave the domain and range for each. Now we're going to talk about functions. When we have a function, we're talking about relations. Now, a relation is considered a function if each member of the domain, or the x value, goes to exactly one member. That's what's important, meaning that every x value only goes to one y. All right, and today I'm going to show you, well, with this example here. This is called mapping it, when you write all the domain down and then all the range right below it. So here, on this first one that I'm starring in green, we take a look. We have our domain, or our x value, and here we have our range. Now what we have to decide is, does each x value, or does each number in the domain go to only one number in the range? Well, 0 goes to 1, so that's okay. 2 goes to 4, so that's okay. But take a look at 1 here. All right. It goes to both 2 and it goes to 3, meaning this is not a function because it can only go to one number. All right, and here 1 goes to 2 and 3. Now on the second example here that I'm starring in blue, I can take a look. 1 goes exactly to 1, 3 goes to 0, 4 goes to 4, and 5 goes to 2. So each x value, or each number in the domain, does go to only one number in the range. So this is a function. All right. There we go. So now we're going to do this with the next couple examples. It says, is each relation a function, and explain? And again, again, this is when we map the diagrams. And this box right down here at the bottom that I'm kind of moving on you tells you what to do. First step is to write the domain and range from least to greatest, meaning what we're going to do is exactly what you saw on the last page. You're going to write domain, you're going to write range, and then you're going to write those values in from least to greatest. So I'm going to do my domain or x values first, 0, 1, 2, and 3. I'm going to just list them. All right, and then I'm going to do the same with the range. Well, my range is 5, 6, 4, 7. Again, I want to write them from least to greatest. 4, 5, 6, 7. So that's step 1. Step 2 says now make the arrows. Actually find out where each one goes. So I go back to A where it says 0 goes to 5. So make an arrow. 1 goes to 6. 2 goes to 4. And 3 goes to 7. So I take a look. Does each x value go to only one y or one number in the range? And it does. So yes, this is a function. Now we can try B the same way, and again, I'm going to go through this one quickly, and the next two are yours to practice. So domain, range. So my x values, I have 0, 1, 2, and 3. In my range, I have 5, 5, 6, 7. Again, even though they have 5 written down twice, you only write it the once. So 5, 6, 7. Now I go ahead and make my arrows. 0 goes to 5, 1 goes to 5, 2 goes to 6, 3 goes to 7. So now I take a look again and I see, does each x value go to only one y? So 0 goes to 5, 1 goes to 5, 2 goes to 6, and 3 goes to 7. Now, some people will look at this part right here and get confused. All right, and they say, no, it's not a function because 0 and 1 both go to 5. But it's only if one of these numbers in green, the 0 or 1 under the domain, goes to a different range. So this is actually considered a function because each x value only goes to one y value. Now, a different situation would be if 0 went to 5 and then it also went to 6. Then it would not be a function because 0 has 5 and 6. All right? So just watch that. All right, so now it's your turn. Here are the next two, and I want you to do the mapping piece and then decide if it's a function. So go ahead and pause me now. All right, let's go ahead and check them. So again, I'm just writing the domain or x and then the range. And for my domain, I have -2 and 2. And for my range, I have -2, 2, and 3. So now let's go ahead and do this. -2 goes to 3, 2 goes to 2, and 2 goes to -2. This, well, is not a function because here 2 goes both to -2 and 3. So this is not. All right, and then again, we do the same with D. And I list them all, 0, 1, 2, and then 1, 2, 3. Well, 0 goes to 1, 1 goes to 3, and 2 goes to 2. Each one x value only goes to one y value, so it is a function. There we go. Now, sometimes we deal with these in word problems, meaning that it can model a situation that we actually deal with. And you have to decide, would it be a function of the other? Does one thing affect the another piece? For example, miles to gallons. All right, if I say I can only, do the number of miles you go depend on the gallons, and that would be yes. Because if you only put in 1 gallon of gas, well, you're not going to get near as far if you filled up your tank with 10 gallons. Or same with hours and wages. The number of hours you work, well, the higher your wages are going to be. So one affects the other. So here, is the time needed to mow a lawn a function of the size of the lawn? Explain. So here, if we're thinking about mowing some lawns, you would think, well, with a small lawn, maybe it would only take an hour or two. And with a bigger lawn, you'd say, well, it'd probably take a little longer. But then you have to think of maybe all the little things that can make a difference. Like maybe you stopped and took a break halfway through. Or maybe somebody had a push mower for that small lawn, but then they used one of the ride-along ones and got a bigger one done. So the time needed to mow a lawn a function of the size? I'd say no, because there's all the sorts of dependents that can make it different. right? And then here we have this one. Is the time needed to cook a turkey a function of the weight of the turkey? So I don't know if you've ever watched your parents before cook a turkey. Usually, if you have a big family, you want a bigger one. If you have a smaller family, maybe you take a littler one. But does the time that it has to be in the oven relate to how big the turkey is? And in this situation, it'd be a yes, it does. Because the bigger the turkey, the longer it would take to cook. And again, so if you only had a 1 pound turkey, it's going to be done a lot faster than a like 6 or 10 pound turkey. All right, so yes, that would be considered a function. All right, so that was that piece. So we've already talked about relations versus functions, and I showed you how one way you can determine if it's actually a function. Now I'm going to show you another way to determine that. All right, and that is called the vertical line test. And right here I have the definition, and the whole idea is if you can roll a pencil through 2 points on the graph at once, it isn't a function. Meaning what we're going to have to do here is graph the points, or graph the relation they give us, and then see, well, if we can go through one or more than 1 point at a time with a vertical line, meaning an up and down line, that would not make it a function. So here, I have a few examples. This one, I have a parabola, and here, I could just start making vertical lines through it, and you can start noticing right away. Well, I cross the line here, and I cross one here. I cross one here, and here. Here and here, here and here. So you can see I cross more than 1 point at once, so this is not a function. Now on the next one, number 2 here, I can make some lines. And if I take a look, I have that blue line, and I only cross it at 1 point each time. So this is a function. Okay, and then the final one, all right, oh, I start good here, only once, and then poof. Well, I cross the line 3 different parts of the graph. So just because I cross it at 3 different points here, it is not a function. All right, so this is what we're going to do. We're going to graph those relations and then do the vertical line test. So I have this one. And part A says graph the relation shown in the table, and then B says to determine if it's a function. So we're going to graph it. So domain, again, just means x. Range means y. So again, I could rewrite these as negative 3, 5, negative 5, 3, 3, 5, and then 5, 3. All right, so I start doing this. Well, negative 3 and up to 5, negative 5 to 3, let's see, 3 to 5, and then 5 to 3. So I have all 4 points, and now I start doing a graph. Well, I cross 1 point there, cross a point there, only 1 there. Well, it looks like I only crossed 1 point with the vertical line test. So, yes, this is a function. All right, and again, because, well, why is it? Because I only go through 1 point at a time. And again, you're always going to make vertical lines to test these. You're not going to be making any horizontal ones. So this is a function. Next, I believe I have another one for us to try, and it's your turn. So again, graph the relation shown here, and then determine if this relation is a function. So go ahead, pause me, and test it out. All right, so it's my turn to graph them now. So negative 1, 4. 2, 3, 4, negative 1, and negative 1, negative 2. So again, now that I have them all graphed, I start, oops, that one was a little off. I'm going to fix that before I actually graph it. So negative 1, 4, right there. So now I do the vertical line test. And again, I go through my first line that has points, and I take a look. Well, here, I already can tell. But I'll graph all of them. Here I only cross through 1 point. Here I cross through 1. But this first line, I cross through 2 points. So this is not a function. And why? Well, I go through 2 points. All right, and I go through those 2 points at 1, so that's how I know it is not a function. All right, so that's your lesson for tonight. Tonight we explained what relations were, and then we determined if relations were functions using either mapping or using the vertical line test. You have a great night, and I will see you all tomorrow.